Bonding the structural steel to the cold water electrode fulfills multiple electrical code requirements related to grounding and bonding. The cold water electrode serves as the primary grounding electrode for the electrical system. Section 250.53d2 of the National Electrical Code, or NEC, mandates that a cold water grounding electrode must be supplemented by an additional grounding electrode. Acceptable types for this supplemental electrode are outlined in section 250.52 upward through A7. These electrodes can include things like ground rods, ground rings, or concrete encased electrodes, among others. Now consider the option of using structural steel as the supplemental electrode. Section 250.52 at Wattsworth provides that structural steel can be considered effectively grounded if it is bonded to the cold water electrode. This is a critical point. Bonding refers to the practice of intentionally connecting metallic parts to create a low impedance path for fault current. In essence, it ensures that all metal components are at the same electrical potential, minimizing the risk of electric shock. When you bond the structural steel to the cold water electrode, you are essentially killing two birds with one stone. Firstly, the cold water electrode provides the main grounding path, as it is designed to do. Secondly, by bonding the structural steel to this electrode, you satisfy the requirement for a supplemental grounding electrode. Furthermore, this bonding also fulfills the necessary conditions for considering the structural steel itself to be effectively grounded. This technique streamlines the grounding process, ensuring compliance with the NEC while effectively protecting the electrical system and personnel. To reiterate, there are three main concepts here. Firstly, the primary grounding of the electrical system using the cold water electrode. Secondly, the supplemental grounding achieved by bonding the structural steel. And thirdly, the bonding requirement itself. Let's delve deeper into each of these aspects. The cold water electrode is typically a metallic water pipe that is in direct contact with the earth for at least 10 feet. It provides a direct path for fault current to return to the source, helping to trip over current protection devices like circuit breakers and fuses. Without a properly grounded system, fault currents could linger, creating a shock hazard and potentially damaging equipment. The NEC outlines specific requirements for the size and installation of grounding electrodes to ensure their effectiveness. The supplemental grounding electrode, in this case, the structural steel, acts as a backup to the cold water electrode. It provides an additional path for fault current, enhancing the overall reliability of the grounding system. In situations where the cold water electrode might become compromised, the supplemental electrode ensures that grounding is maintained. As for the structural steel to be considered as an effective supplemental ground, it is important for it to be mechanically sound and of adequate size. The bonding requirement ensures that all metallic components of the electrical system are at the same electrical potential. This is crucial for preventing dangerous voltage differences that could lead to electric shock. When a fault occurs, the fault current will flow through the grounding system, raising the potential of the grounded metal parts. If there are unbonded metal parts nearby, a voltage difference can exist between them, creating a shock hazard. By bonding all metal parts together, you minimize this voltage difference and create a safer environment. The NEC specifies the methods and materials for proper bonding. Bonding conductors must be sized appropriately to handle the available fault current. Connections must be made using approved methods and materials to ensure a reliable and low impedance connection. Now let's discuss how to correctly install the bond between the structural steel and the cold water electrode. It's essential to use a bonding jumper of the correct size, as specified by the NEC, based on the size of the service entrance conductors. This jumper should be securely connected to both the structural steel and the cold water pipe using approved fittings. Clean the surfaces of the steel and pipe to ensure a good electrical connection. Remove any rust, paint, or other non-conductive coatings. Use a suitable bonding clamp or lug to make the connection and tighten it securely. Protect the connection from corrosion by applying a corrosion inhibitor. This will help to maintain the integrity of the connection over time. Inspect the connection regularly to ensure that it is still in good condition. If you find any signs of corrosion or damage, repair or replace the connection immediately. It's also important to ensure that the structural steel itself is adequately grounded. This may involve bonding different sections of the steel together to create a continuous grounding path. The NEC provides detailed requirements for grounding structural steel, which you should consult before beginning any work. Remember to always de-energize the electrical system before working on any grounding or bonding connections. This will help to prevent electric shock. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Grounding and bonding are critical for electrical safety, and it's important to get it right. Improperly grounded or bonded systems can create a serious shock hazard. Here's a recap. Firstly, ensure the cold water electrode is properly installed and meets NEC requirements. Secondly, bond the structural steel to the cold water electrode using a correctly sized bonding jumper and approved fittings. Thirdly, inspect the connections regularly and maintain them in good condition. And fourthly, if in doubt, consult with a qualified electrician. By understanding these principles and following the NEC guidelines, you can create a safe and reliable electrical system. It is useful to understand the importance of proper grounding and bonding in maintaining a safe electrical system. The grounding system provides a low impedance path for fault currents to return to the source, tripping over current protection devices and preventing dangerous voltage buildup. The bonding system ensures that all metallic parts are at the same electrical potential, minimizing the risk of electric shock. By combining these two systems, you create a comprehensive safety net that protects people and equipment from electrical hazards. The NEC is a comprehensive set of rules and regulations that govern the installation of electrical systems. It is designed to ensure the safety of people and property. It is important to be familiar with the NEC requirements for grounding and bonding before beginning any electrical work. If you are not sure about something, consult with a qualified electrician. They can help you to understand the NEC requirements and ensure that your electrical system is installed correctly. There are several resources available to help you learn more about grounding and bonding. The NEC is a valuable resource, as are electrical engineering textbooks and online resources. You can also find training courses and workshops that cover grounding and bonding in detail. Consider taking a course or workshop to improve your knowledge and skills. Grounding and bonding are not just theoretical concepts, they are practical skills that can save lives. By taking the time to learn about these topics, you can make a real difference in the safety of your home or workplace. When dealing with electrical systems, always prioritize safety. Wear appropriate personal protective equipment, such as gloves and eye protection, to energize the system before working on any connections. And if you are not comfortable working with electricity, hire a qualified electrician. They have the knowledge and experience to do the work safely and correctly. Remember to consult with local building codes and regulations, as they may have additional requirements for grounding and bonding. Compliance with these codes is essential for ensuring the safety and legality of your electrical system. Document your grounding and bonding system. Keep records of the materials used, the connections made, and the test results. This documentation can be helpful for troubleshooting and maintenance in the future. It can also be required by inspectors or insurance companies. Understanding the principles of grounding and bonding and following the NEC guidelines is essential for creating a safe and reliable electrical system. By combining a cold water electrode with bonded structural steel, you can achieve both primary and supplemental grounding, meeting the requirements of the NEC in protecting people and equipment from electrical hazards. Always remember that electricity can be dangerous, and it is important to take precautions to protect yourself and others.